Okay, I got out on a perfect evening the other night, probably midweek or so, and flew around, made a low pass at my little airstrip, and I realized there are no safe landing zones other than the runway. It is just solidly surrounded by trees. Flew around for a while, tried some steeper banks in combination, left turns, right turns, aggressive changes from descent to climbing, and had a general feeling of much more comfort underneath this glider. I returned to the field, but man, the wind cramming into this Y-shaped canyon of trees literally made my landing and approach feel like I was trying to stand on a beach ball. Oops.
Chip, I don't think I can get in there. I think I'm going to have to go down here.
After my second aborted landing and a wave to my favorite farm family, I decided I was going to nail it right from the middle of the field and just take whatever happened.
Man. Well, I guess you could say the paradox on the paradox. Added these cool reflectors, and it's one pin removal. There's a cotter pin clip. Just pull this retainer clip out of the other end of this. Pull this pin. Hopefully you don't lose that while you're paramotoring. And then this whole thing just kind of slides off of here. I'll show you how it retains once I pull it off. So the tail end of the frame is captured by this pin. It goes through the lower portion. And then the front, the crumple zone, just goes underneath here. That easy. Hardly even rattles. So it gives me about the perfect height to pick up and put down the motor section without having to bend down and do it off the ground. I added a couple reflectors, even that one underneath there. I don't know if you can see it or not. That probably means it meets DOT specifications in at least 30 of the 50 states. So get off the couch, put your computer down, go out in the garage and weld up one for yourself.
Let's drive to Florida.
Light wind, so you do it. Have you done it forward yet?
Yeah, I don't like them. I gotta run too fast. Yeah, that's kind of why I mean, when I tried to kite back up the hill, I couldn't.
Yeah. What you do is bring it up halfway, and just walk towards it and send it back down. You really can't get it above your head.
Yeah.
On the reverse, you know, when you're bringing it up, hold your aid, move back with it, turn. You have to keep moving immediately. Okay, then you can introduce power just a little bit and get it under control.
So if there was such a thing as a PPG dictionary, and you looked up the word integrity, you'd find a picture of this guy. His name is Eric Cote, and he runs a PPG school called Paradise PPG.
Turn, that means it's in a good position, and you're
Yeah.
ready to go after that, okay?
Yep. From the very first moment when I contacted Eric, I told him I had no intention of purchasing training from him. Yet he worked with me to ensure that the equipment that I selected was the best fit for my weight and my flying style as I had articulated it to him. And he worked to be sure that the equipment that I got fit me very well. Because of my experience with Eric helping me with equipment, I came back to him for some pointers to make sure that he took a look at what I was doing, make sure that I had ingrained any really bad, dangerous habits, and to just generally look over the safety of my stuff.
That's all I've been doing, you know.
That's it.
I don't
And
think the
just hold it
criticisms
there.
were
Just
valid
hold it
there.
there. Don't go any
Yeah,
further.
I hold it there, and when I get airspeed and get airborne,
If there's more wind,
milk 'em up.
more brake you can use because there's more wind holding that wing up.
Right.
Less wind, less brake because you pull too much and it's just going to fall down. So wait till you build the speed up with less wind. Wait till you build the speed up, then introduce your brakes and just hold that there. Keep on running.
I saw you on the way in, you were kind of crabbing, and you turned at the last minute.
Yep. So here,
Um,
you can do a dry run too. You know, see, don't try to land the first time. You know, follow high up on the bank, and at the last minute, just slowly start your turn. Now you're going to be heading south, and you're going to be turning to the left. Okay. So we're coming in, and you see the ground somewhat 6-7 feet up. At that point, you're going to start pulling just a little bit of left. You're not going to do anything with this hand. Once you start pulling left, don't let it up because you're going to swing back the other way and then you're going to end up landing that way and eat it. Okay, so you start pulling. I tell my students fingertip pressure because you get your fingers like this. Just a little pressure just so it starts to make its way in. And as you're almost getting directly back into the wind,
add in the
start
right
applying
brake.
just a little bit of the other one. You don't have to flare yet.
So here's what I learned this week. Laminar onshore winds make this so easy.
Well, let's see what we got here. Yeah, right. I feel like a freaking amateur.
So after flying for a while, Eric talked me into a landing and walked me through the geometry of his home stomping grounds.
Good job. Good
Yeah.
job. Perfect. That was nice. Beautiful takeoff. Beautiful execution. Loving it.
Good.
Loving it.
So,
That's good. It almost looks like you have training. Awesome.
I do, you!
Yeah, well,
Now I can say I have
I just
training.
helped you. I just made sure everything was good.
That's funny.
That was freaking awesome.
So here's this video section about what I do know. Because I'd worked for an airline for so many years, they ensured that I knew an awful lot about aerodynamics. If you're not interested in aerodynamics, particularly the aerodynamics of reflex wings, you might want to just close the video now and save yourself the agony.
This is my buddy Steve. Hi, Steve. What do you got here? Oh, we're working on an annual or something, huh?
Working on our autopilot controller.
Hey, Steve, how come your license plate has this DF on it? What's that all about?
That's I was awarded the Distinguished Flying Cross while flying helicopters in Vietnam.
Does that mean you're a really good pilot, or was somebody shooting at you?
I was getting shot at.
Man, I'm glad very little of my flying involves getting shot at. And you lived to tell about it.
And I lived to tell about it, yeah.
Thanks for your service, man.
You bet.
Well, anyways, Steve's lucky enough to own one of the most advanced experimental home-built airplanes ever put out there for people to build. What? It's experimental. That can't be safe, right, Steve?
It's absolutely safe
Well, then why do they call it experimental?
because it's not made in a factory. It's not a spam cam.
And it doesn't conform to aircraft certification standards, which exempts the builder from all of that engineering and all of that science and all that documentation that we call certificated airplanes, right?
Yeah, but the kit manufacturer has done all the flight test design, all the design and everything else. They've done all of that as
Okay.
it relates to the kit.
So everything about it's experimental, or does it build on a lot of concepts that are well proven?
Oh, proven concepts.
So you're saying that What? Tell me about the engine. Is that experimental?
No, it's a Lycoming IO 540,
That's a certificated engine.
260 horse with a certificated Hartzell constant speed prop.
Well, what about the avionics? That's all experimental stuff?
Most of it is, yes. It's high-tech, state-of-the-art electronic EFIS electronics that you would pay millions of dollars for, or that people have corporate jets, for example, have the same thing. It costs them millions.
So, this was designed by Van's Aircraft, by Richard Van Runsgren and his group of engineers. So did they invent the wing, or do you think they pulled the wing from a NACA database and used the wing that probably was designed as far back as the 1950s? I know the answer to this question.
I don't know. There is a guy that designed the wing that's alive and living, so I don't know if it's a modification of an existing NACA design or not, so I don't know.
Well, I happen to know. So, tell me about the wing. What do you know about the wing?
It's, from an aerodynamic standpoint, I don't know a lot about it. What makes it unique is the fact that it has reflex flaps.
What? I thought Reflex was a hoax.
No, these are reflex. This is where in the current position where the flaps are now, that is a 3-degree up position, and that allows the airplane to fly faster.
Well, how about that? All right, well, here's what I do know. Tailless airplanes date back to the beginning days of experimental aviation at the government level, back in the post-World War I era, and certainly continued into the post-World War II era, when all this stuff was hammered out. I mean, the federal government employed, your and my grandfathers paid taxes to employ the biggest army of geeks. They didn't even have the word geek or nerd then, and these guys would wear out a slide rule every other week, because they went through and they worked for NACA, the National Advisory Committee on Aeronautics, and they plotted every theoretical wing. They don't even use wind tunnels anymore, because now they do it all with computers. So there's nothing real new about the reflex technology on your wing, because it was included in production airplanes like the Cessna Corvallis, the Dragonfly, the Viscount VC-10. Did you know that was a reflex technology wing?
No.
Yeah, how about that? So in the reflex position, what you're basically doing is putting the flaps up and beyond. So the main design wing chord is one shape, and in the reflex position, the flaps actually have a upward camber rather than a lower camber, and that significantly increases the point at which the laminar flow reattaches to the backside of the wing, and it makes the wing go faster. But that NACA database.
Zero the aileron.
That NACA database has got hundreds, maybe thousands of different airfoils. So anybody designing an airplane can go with a known coefficient of lift, a known lift-to-drag ratio for a given airspeed, and they can design the performance capabilities of the airplane from a database. There's no need to even have wind tunnels anymore. In fact, you can probably buy those old wind tunnel test systems on eBay now, and you don't have to reinvent the wheel, because you can design from a database. Because of the need for certification, general aviation airplanes, and particularly experimental home-built airplanes, are light years ahead of an airliner you might get on. And it takes so much longer to get that stuff through the certification process. That's one of the reasons that the FAA allowed experimental home builds, because there was a clamoring of people that wanted to be able to do this kind of stuff without having to subject themselves to the length of time it took to get through the certification process. When the FAA comes out and says, hey, we are going to go through a rule change, they issue something called a Notice of Proposed Rule Change, and it gives the potential commenters and people with a vested interest time to comment. I don't know if you ever got that one on the airspace that they were messing around with down here, the Gamecock MOA and the Bulldog MOA. They wanted to expand these military operations areas. So those of us that were stakeholders got a chance to comment, and ultimately they only got about a 60th of the airspace that they were actually requesting, because those of us that were flying general aviation said, hey, if you do this and there's bad weather, we don't have any way to get north to south from Florida into the Carolinas because this airspace is going to be so big. So they did the same thing with FAR 103, and the people that were active in it at the time that were into hang gliding and paragliding said, hey, if we could craft the legislation and the rules that govern this activity in a certain way, here's what we would like, and that's how we have FAR 103. It's really, really fantastic that it allows paragliders to be made without having to be subject to this certification process that's prevalent in Europe. So have you ever forgotten to put down flaps and taken off in the reflex mode?
Well, I've done it several times, and if the aircraft is heavy, it increases the ground roll on your departure by a large factor. So you want to, if you're operating from a short strip, either be at 0 degrees or 15 degrees flaps for better takeoff performance.
When I was flying airliners, we had the choice of configuring a wing for lots of different ways for takeoff. And most of the Boeing equipment had fixed gates of 5 degrees flaps, 15 degrees flaps, 25 degrees flaps. And each one served a specific purpose. The 5-degree flap had really high takeoff speeds. But once you got off the runway, you had a lot of energy and you were able to climb in that, what they called second segment, very efficiently. Whereas the flaps 25 setting was a boatload of flaps, but it enabled you to get off of very short runways quickly. The problem was when you got to the end of the runway and you were airborne, you needed 7 or 8 miles of flying distance to clean up and let the wing accelerate and retract those flaps and build up the speed to your climb speed to be able to clear any obstacles like mountainous terrain in the second segment of the takeoff. And it was a poor choice for airports that had particular issues with second segment obstacles. You couldn't use flaps 25, nor would you want to. And there were also times when you didn't want to use flaps 5 because you were screaming along and your ground speed is so fast you were actually exceeding or reaching the tire speed limits of 186 miles an hour or whatever it was for the particular design. Now, the MD-80 and a couple other airplanes had dial flap systems where you could dial in the optimal balance between shortened runway and low speed performance and second segment climb. And that was usually a function of the engineering department and their weight and balance performance calculations. And they would tell us, we'd give them all of our loading information, they would tell us exactly what flap setting to use. It'd be something goofy, something obscure like 11.3 degrees of flap deflection. And that gave us the compromise that was best between runway performance, speed on the airplane, and second segment climb. So the other interesting thing you were saying is
There's speed restrictions on extension of the flaps, whether it's 0 degrees, 15 degrees, or 30 degrees
okay.
flaps. So you've got speeds not to exceed because of structural limitations on it. And when it's in the reflex position, the flaps are in a negative 3 degree position, and they are right up against the hard stop of the wing on the aft section.
Right, so there's no chance of that working or playing, and you're saying in the reflex position, the wing doesn't have any speed limitations,
No.
or the flaps don't have any speed
The
limitations.
flaps don't have any limitations, no.
Yeah.
So the bottom line with reflex wing technology is, it's nothing new and it's not a hoax. It's a part of configurable wing technology. It's a compromise. It allows us to take a wing that has good low-speed performance, and in the air we can manipulate the shape of that wing and increase its high-speed performance. It might not be the best answer for both situations, but it is the best compromise between the two. So here's the important thing. Get into the manual that came with your glider. Read every single aspect of it and memorize it as if your life depends on it, because it may well. One thing is for certain, in most reflex wings there is a chance that use of brakes in the reflex mode will set up a secondary center of pressure on the wing. Two opposed centers of pressure have nothing to hold them apart. It might not be an issue in a rigid wing made out of aluminum, but given that your wing is made out of fabric, it's very important that you don't have two centers of pressure pulling toward one another. It will accelerate wing collapses. So follow the manual and make sure that you understand the manual fully. Here's something that I don't know. How do you determine exactly where your location is on a sectional chart? Is there a digital app on your smartphone that's available to show your exact location and overlay a sectional chart? In the coming days, I hope to do a little more flying with Eric. I actually hope to be able to pry him out of the instructor role and get out and do a little formation flying with him. And just generally enjoy this newfound fascination that I have with flying this glider. So if you have a comment about my question about determining your exact location, please leave me a comment below. And if you haven't already subscribed, please click that subscribe button.
Yeah, I don't want to become a drowning statistic.